everyone. My name's Amber. I'm a machine learning engineer at Arize, and I'm going to be talking to you about fairness metrics in production, when you want to use them, how you want to use them, and how they might pertain to your models in production. If you're not familiar with Arize, it's a machine learning observability platform that helps teams monitor, troubleshoot, and improve models in the real world. I'll be dropping a few links, but you can go to the Arize site, try out the account for free. We probably won't get through a walkthrough today of how you can try fairness checks in production, but you can sign up for yourself and join our active community. All right, the agenda for the talk today is we're going to talk about how bias is found in ML models, when and how to use common fairness metrics, the pros and cons of a lot of these metrics that you have the option of using, challenges with fairness checks in production, and how you can start monitoring your models for algorithmic bias today. All right, so when we talk about bias, what is bias? Well, this is in the context of algorithmic bias. So you might have heard the bias various trade-offs. That's not it. That's not what we're talking about today. It's more the tendency for ML models to not be able to make consistent predictions or consistently making uninformed decisions or predictions for the user. Needless to say, this could be very harmful when users receive these predictions. And bias could get introduced in several different ways. Sometimes it could be insufficient training data. It can be inconsistent inferences. It can be poor data practices. All these together can lead to the model producing a biased decision. So it's best to have best practices, and we're going to get into exactly how you can enable those today. Before we get into the metrics, I think it's important to talk about the features, which are essentially going to be the attributes that your model is protecting against. There's a lot of federally protected attributes, and so some teams will decide to either remove these attributes or obscure them. They really don't want any decision that they're making to be kind of based solely on these attributes. But there's certain cases where you need these protected attributes, things like the healthcare space, for example. You're going to need to know the age and the sex of the user, of the patient, for example. They're going to need to be able to make diagnoses based on these protected sensitive attributes. So you just want to make sure your model is behaving fairly in production. And the type of biases that we tend to see, we actually have a free course as well that really dives into these types of bias. It's kind of an intro to ML observability course, and there's a full unit that dives in deeper to these. This talk's going to be primarily focused on the advanced metrics that you'd be using. But just to give everyone an understanding, we have data biases and model biases that come into play. A lot of the data biases are around things like tainted samples, historic bias, skewed samples, and then you have measurement bias, which is kind of a class imbalance problem where you have a very small minority class, and even if you do techniques to try and increase that sample size disparity, you might have data that's just not very correct, very accurate, and you might not have enough accurate data for your model to make an informed decision. Another common way that bias is introduced in production is through proxies. You heard me say that there are some teams that will simply eliminate those protected attributes. But if you're using something like zip code in your model can still make a biased decision because something like zip code is a proxy to a few of those protected attributes. And then when we look at what can happen with the model itself, essentially, there's not a one-size-fits-all model for certain predictions. And if you try and take one model and just use it for a different purpose and repurpose it, they could have unintended consequences. And that's why you also have to be aware of the benchmark that you're using. Your benchmark is your measure of success. So making sure that it's generalizable is going to be key to try and mitigate this bias that you may find in production. Okay, so that's a bit on the background. How do we actually tackle bias in the fairness pipeline? You might have heard the processes of preprocessing, in-processing, and post-processing. These are essentially the parts of your ML pipeline or data pipeline that fairness can intervene. So when you look at pre-processing, you can see it's more to do with the original data, the data going into the model. In processing is that actual model development experimentation phase. And then you have post-processing, which is after the model is created. And again, so pre-processing, this is going to be the earliest stage of data processing, where you're creating all these inputs. And this is the ideal place to start with eliminating bias and implementing best practices. In processing is the training process of the model. So this is where you want to make sure any hyperparameter tuning, retraining processes are keeping fairness in mind. And then post-processing, this is the very last part. It takes place after the model has been trained and processed on, and had been trained on the processed data. And this is not where you want to try and intervene with fairness, but is for some teams, that's the only option they have. If you're using something like ChatGPT, you don't have access to the pre-processing, and for certain models, you don't have access to in-processing. So if you're using a different model, or if you're a team that inherited a lot of models where you don't know where that pre-processing and in-processing steps are, you might only have access to that endpoint. Ideally, you're inserting measures to detect bias at each stage, but for certain models, you're not going to have access to each step. And so what we're actually able to do, so say you do have full access to all the model stages, and you can intervene in the pre-processing step. So you can remove, obscure, rename the sensitive attributes, and then you can go into the in-processing. So this is taking into account regularization, making sure one feature doesn't have a dominant impact over another model's feature. You can also use explainability to see the most important features that are responsible for your model's decision. And you can use an adversarial approach to try and make sure your model is making the most informed decisions as possible. And like I said, with the post-processing, at that end stage, you can't really go back and make these pre-processing and in-processing steps known. But what you can do is something that's called a black box auditing tool. You can use bias tracing, so you can map back decisions to the data, or at least the data that you have. And then you can, have a middle step, essentially, where before that decision is given to the users, there's some kind of middleman that will look at that decision, even if it's just a model that's trying to understand if there's algorithmic bias involved. That's that middle step before it actually gets to the user. And when we talk about, who are these users, who are we creating fairness for, it tends to be either at the group level or the individual level. So if you have group fairness, you tend to be looking at protected attributes of a group or a cohort, making sure that everyone that is part of a given group is being treated fairly against all other groups, or individual fairness, where you're making sure an individual is receiving similar treatment as every other individual in loans, for example. Like if you're giving you're seeing who is going to get a loan approved, you might say, okay, I want to make sure applicant, number 5 is getting the same treatment as every other applicant in our system. In terms of prevailing model fairness metrics, again, you first have to decide, am I looking at the group level, or am I looking at the individual level? Am I looking at representation or accuracy, essentially, for an individual? Once you make that decision and say you are looking at the fairness of a group, you have to decide, are you looking at equal numbers or are you looking at proportionality? If I'm looking at equal numbers, I might say, okay, if I'm running a college admissions board, I might say, okay, we want equal numbers of one group and equal to another group. If there's two groups applying, we want to make sure equal numbers. And then there's proportional parity, which is saying, okay, I want to make sure of these two groups that apply, we're letting in proportional numbers. So if you have 70% of applicants are group 1 and 30% of applicants are group 2, you want to make sure that the final result of who's coming to the university has a 70-30 split. And these are just examples of parity measures that you can implement. If you are looking at the individual level, so the decision made for the individual, the next thing you have to think about is this going to be a punitive or assistive decision? Punitive for punishing, essentially. If you're dealing out a sentence, that's a punitive decision. If you are wrong about that decision, it could have devastating consequences. So you might want to have something like, maximize for certain either false positives, false negatives. You might want to minimize for certain key elements there. So we might look at a false positive rate parity. If it's an assistive decision, like maybe you're deciding who's going to get a promotion, you want to make sure those with adequate experience are the ones getting rewarded. But, if you don't maximize for the same things that the punitive decisions for, it's not going to be as devastating. The next thing to think about is the volume or kind of class imbalance for those decisions. And then this is going to help give you the metric that you should be using dependent on your use case. And just to dive into a few of these, we recently had a blog post come out that really details each one of those metrics if you're interested in learning more. But just to take a little excerpt from that blog post, we have recall parity, false positive rate parity, and disparate impact. We see these being the most commonly used metrics in industry today. Again, it's dependent on the use case, but these are what a lot of teams are implementing. Recall, we know, is also known as the sensitivity. So it measures how sensitive the model is for one group compared to another. False positive rate parity, we're measuring whether a model is incorrectly predicting the positive class for a sensitive group compared to a base group. And as we saw here, like the false positive rate parity, you would want parity close to 1, especially if it is a punitive decision. For disparate impact, that is going to be when we're talking about that proportionality, the proportionality parity for overall populations and for group parity. For parity checks, we have different types. So the way you think about like type 1, type 2 errors, if you want to generate a report for your team or for customers on how the models are doing, you can use things like type 1, type 2 parity to quantify bias. So making sure there's parity between the given metrics that are of your interest. And when I say parity, so essentially dividing one over the other, parity of one is perfect parity. It means your model's acting in the same regards for one group or one individual to another group or individual. But what can be a good range is known as the 4/5 rule. So the 4/5 rule is a threshold. It's commonly used in regulatory agencies like the United States Equal Employment Opportunity Commission. And essentially, it's saying if you have a parity between 0.8 and 1.25, that's a good parity score. It likely means there isn't algorithmic bias that's being introduced when comparing one group to another group. And if it's much larger or smaller than that threshold, to take a closer look at the data. A lot of times the challenges that are involved in monitoring for these fairness models include a lack of access to the attributes for modelers, especially within large teams. A model can go from like version 1 to version 6 before deployment. And during that time, there's a loss in understanding of what features do what, a loss in documentation. Once the model even gets to the modelers, they maybe say the features are renamed. So, you try to be as fair as possible, but things can change in that time frame. So having access and a lot of just conversations and documentation around the protected attributes is going to be key. And having consistent ways to check for model bias. That's another thing. A lot of times what teams are finding is that they're getting calls from customers, from other team members, from higher ups, but a lot of times it is from the customers or users calling to complain about the decisions they're receiving. And so that's really the last things we're going to want. So having ways of easily checking for bias is going to make it that much easier to maintain these models in production. There's also a trade-off between fairness and business impact. So making sure that goes back to making sure that these checks are easy and consistent to do, and that they're implemented and thought about at the beginning of these processes. And then just having diffused responsibility across teams and orgs. It's really the responsibility of the entire team or company to think about responsible AI, to think about fairness in production, but it's no one's direct assignment in many companies to implement fairness checks. So, having team managers like asking the right questions, having engineers aware of best practices before deploying their model and after their model is deployed are going to be key in making sure that everyone is responsible, but also actionable. Like you can actually do something about these fairness checks in production. In terms of how teams can actually resolve these model biases in production, again, that's step one, make those protected classes available to modelers or team, or label them or put them in the documentation so teams know which features correspond to protected classes. So like I said, for some models, you actually do need that information. You just want to make sure that that's being heavily monitored and someone has an eye on it, and then implementing the fairness checks. But having full knowledge like between team members is going to get everyone on the same page, and then they're able to ask about the features. Step two is to ensure you have the tools that make those steps easier. So you have the tools in place that can actually check for bias in production, make the work easier, and it alleviates a lot of stress around the problem as well. When we see more and more companies running into issues with fairness in production, you can know that you're actively checking your own models in production. And then step three is essentially an internal, having an internal change agent, having someone that knows what to do when they see this bias, because, models break all the time. Obviously, we don't want these models to be biased in production. And even if you clean the data and the data is checked by a lot of individuals, stuff can still happen, especially with new incoming inferences in production. So having someone in play that knows what to do when this happens, a lot of times that could just be putting in a practice. Like when you do detect algorithmic bias, detect where it is in the data. Maybe you take that model down from, you put in like a shadow model, you take that current model down, you fix it. And then once you know the process, you can easily fix it within your team, get approval, and then get it redeployed. And we talked a lot about parity checks, essentially trying to get that parity score of 1 to make sure that you do have fairness in production. What we haven't talked about a lot is bias tracing. So if a model is exhibiting bias, what you can do to actually root cause and pinpoint those issues that you're having in production. And with bias tracing, these steps that you take in production are you make these multidimensional comparisons. Essentially, when you're doing bias tracing, it's similar to performance tracing. If you're familiar with ML observability or Arize, you might have run into it previously. Essentially, you want to be able to establish a baseline and then look at your production data. So if your production data is coming in and it's as expected from the baseline, then that's going to be good. That's going to meet expectations. When you're doing fairness checks, what you can do is look at certain time windows in any data set. It could be training, it could be validation, it could be production, but you want to be able to compare cohorts or individuals directly. So that brings me to step 2, where you actually select, like, what is my sensitive attribute? Do I want to select and see how the female applicants are doing compared to all other applicants in my model? I can select any sensitive attribute, any group of sensitive attributes, and compare them to essentially a base group or every other group. So you want to be able to add those group to group or individual to group comparisons directly and calculate that parity. That brings me to step 3. You have, after defining these parameters, you want to be able to then put in your parity metric and do that calculation. So you're constantly running parity checks in production. So we are about out of time, but I did want to just show that you can test this out for yourself with the Arize platform. It takes a few minutes to set up, but you can create your own account. You can also go through the quick start guide that will take you through the fairness tracing in production. But we have a fairness demo. So all these are demos. You can go and select on it, and we're just going to go right into fairness. If you have any questions on the platform or other tabs, just let me know through that community Slack. I'm also amber@arize.com if you have any follow-up questions. But essentially here we can select the data set. We can add the comparison. So say we look at 2 production comparisons. I can look at 2 different time ranges. I can look at when parity has spiked, and I can select a metric of my choosing. We also do have custom metrics now available. But say I want to look at my false parity rate. I want to select a feature or a tag, which is metadata, and then I can select an attribute. So any attribute, I'm going to choose race as my attribute or feature that I'm selecting. I can select a base. I can make my base a set, or I can make my base Caucasian if I'm looking at race, and I can select a sensitive group. So maybe I'm going to select Latino, for example. I can also select several base groups, and then I can calculate my parity score. So again, you are wanting to look for parity scores that are close to 1. Our parity score is a bit high here, and then we're able to dive in and figure out where in the data that is causing that parity score to spike. I have some more information and resources. If you're interested, please reach out. I'm also going to be answering questions in the chat. So if you have any questions, please let me know. But thank you, everyone, and I hope you have a great rest of your day.